Hello everyone. Today I will be guiding you step by step through the process of training a LoRa on the latest state-of-the-art text-to-image generative AI model Flux. Over the past week, I have been deeply immersed in research, working tirelessly to identify the most effective training workflows and configurations. So far, I have completed 72 full training sessions and more are underway. I have developed a range of unique training configurations that cater to GPUs with as little as 8 GB of VRAM all the way up to 48 GB. These configurations are optimized for VRAM usage and ranked by training quality. Remarkably, all of them deliver outstanding results. The primary difference lies in the training speed. So yes, even if you are using an 8 GB RTX GPU, you can train an impressive Flux LoRa at a respectable speed. For this tutorial, I will be using Kohya Gai, a user-friendly interface built on the acclaimed Kohya training scripts. With this graphical user interface, you will be able to install, set up, and start training with just mouse clicks. Although this tutorial demonstrates how to use Kohya Gai on a local Windows machine, the process is identical for cloud-based services. Therefore, it is essential to watch this tutorial to understand how to use Kohya Gai on cloud platforms, even though I will be making separate tutorials specifically for cloud setups. We will cover everything from the basics to the expert settings. So even if you are a complete beginner, you will be able to fully train and utilize an amazing Flux LoRa model. The tutorial is organized into chapters and includes manually written English captions, so be sure to check out the chapters and enable captions if you need them. In addition to training, I will also show you how to use the generated LoRa's within the Swarm UI and how to perform grid generation to identify the best training checkpoint. Finally, at the end of the video, I will demonstrate how you can train Stable Diffusion 1.5 and SDXL models using the latest Kohya Gai interface. So I have prepared an amazing written post that you will find all of the instructions, links, and guides for this amazing tutorial. The link of this post will be in the description of the video, and this post will get updated as I get new information as I complete my new research with the new hyperparameters and new features. So this post will be your ultimate guidance to follow this tutorial to do Flux LoRa training by using the Kohya Gai. Kohya Gai is a wrapper developed by the Bumaltais that allow us to use Kohya SS scripts very easily. This is its official GitHub repository. Basically, we are using Kohya SS. However, we are having a GUI and one-click installers and easy setup to use the Kohya SS scripts. So you will see that I have a zip file here. When you go to the bottom of the post, you will also see the attachments, and in the attachments you will see the zip file. I may forgot to put the zip file to the very top of the post, but when you look at the attachments, you will find the zip file always. So let's download the zip file. Click here. Move this zip file to the any disk that you want to install. I am going to install it into my R drive. Do not install it into your Windows folder, into your users folder. Directly install into any drive, or do not install it into your cloud drives. Okay, right click and extract. Enter extracted folder and you will see all of these files. These files may get updated and there may be more files when you're watching this tutorial. Don't get confused. I will update everything as they be necessary. Currently, the main branch of the Kohya Gai doesn't support the Flux training. You see there is SD3 Flux branch. So my installer will automatically switch to the Flux branch and install it for you. Once it is merged into the main branch, main repository, I will update my installers. To install Kohya Gai, we are going to use Windows install step 1 bat file. Double click it. It will clone the repository, switch to the accurate branch, and it will start the installation. For this to work, you need to have requirements installed. you will see that we have Windows requirements section. We need Python 3.10.11, FFmpeg, CUDA 11.8, and C++ tools and Git. Now, once you install these, you will be able to use all of the open source AI applications like Stable Diffusion, Automatic 1111 Web UI, Forge Web UI, OneTrainer, Swarm UI, Conf UI, whatever you can imagine, like Raw Perl, Face Fusion, and such things. So I have a very good tutorial that I have shown how to install all of these. Please watch this tutorial, do not skip it. Please make sure that your Python is directly installed into your C drive. You have installed the FFmpeg, CUDA, C++ tools. These are all important. How you can check whether you have installed or not? Type cmd and open a command prompt like this. Type Python and you should get 3.10.11. Open another cmd and type git and you should get git code like this. Open another cmd and type ffmpeg and you should get ffmpeg. Ffmpeg is not necessary for Kohya, but you should install it because you may use other AI applications. And type nvcc version, and this will let you see whether you have installed accurate CUDA or not. Everything is explained in this video. Please watch it to not have any errors. So the automatic installation will ask you these options. We are going to select option 1 and hit enter. Then this will start installing the Kohya SS GUI latest version to our computer. Currently we are in the accurate branch. As I said, I will update this branch when it is merged into master branch. Just wait patiently. You see that it is showing me I have Python 3.10.11. It is installed and it is going to download and install everything automatically for me. So the installation has been completed and I have the new options. You should scroll up and check whether there were any errors or not, because the installation step is extremely important. So scroll up and check all of the messages. So as a next step, we are going to set the accelerate, because in some computers it may not be set accurately. So type 5 and hit enter. It is going to ask us some of the options. We are going to use this machine, hit enter. We are not going to do distributed training, hit enter. We are not training on Apple or anything. We are training on CUDA drive, so no. We are not using Torque Dynamo, no. We are not using DeepSpeed, no. We are going to use all of the GPUs, so type all and hit enter. I also say yes to this, but I didn't see any difference, hit enter. And we are going to use BF16, this one. So select this one and hit enter, and we are ready. And we are ready. You don't need to do option 2, option 3, option 4. But we are not going to use option 6 to start yet. So hit 7 and hit enter. Return back to the folder. And whenever you are going to start training or after initial installation, run this bat file update Kohya and fix Flux step 2. This is going to upgrade to the latest libraries. It is going to also update the scripts to the latest version. So we are going to have the very latest version with this bat file. I will keep these files updated. Just wait to install everything. The steps are also written in this post file, but watching this video is better. And the updates have been completed. Verify that they are all working. We are currently using Torch 2.4.0 and it is working slow on Windows compared to the Linux systems. However, with Torch 2.4.1, hopefully this speed issue on Windows will be fixed, and as soon as it is released, I am going to update my installer scripts. There have been a new development after I have completed the tutorial video, which is Torch 2.5 version. With this version, there is a huge speed improvement on Windows. It is almost as equal to Linux. However, Torch 2.5 version is currently in development, so it may be broken, it may give you errors. I also didn't test its quality yet. Hopefully I will test it and I will update the Patreon post. You see it is already updated. The file that you need to use is install Torch 2.5 dev huge speed update bat file after completed the installation. As I said, this is experimental, and follow the news on the Patreon post. And now we are ready to start using the Kohya SS GUI. So for starting the Kohya SS GUI, you can either enter Kohya SS folder and start the GUI.bat file, or you can use my automatic starter file, which is Windows Start Kohya SS.bat file. This will automatically start and open the browser. You see the interface has started. If it doesn't start, you need to open this manually. Alright, now this is the interface of Kohya. It is very useful and easy to use. Very important thing that you need to be careful is that you need to select LoRa, because we are currently training LoRa. LoRa is optimization, so it is different than Dreamboot. Dreamboot is basically fine-tuning, training the entire model, but with LoRa, we are only training a certain part of the model, thus it is lesser hardware requirement but also lesser quality. Currently this tutorial is for LoRa training. Hopefully I am going to do a full research on Dreamboot fine-tuning and publish another tutorial for that, and I am going to publish configurations as well. So this tutorial is so far the combination of over 64 different trainings. This is literal. When you go to this post, you will see the entire research history. This is a very long, lengthy post. You will see all of the tests I have made. You will see all of the results, grids, comparisons. I am also going to show some of the parts in this tutorial. So read this post if you want to learn how I come up with my workflow, with my configuration. Also, when you open this post, you will see all of the models that I have prepared up to now. And this is not all. Currently, I am running 8 different trainings on a 8X RTX A6000 having GPU on massive compute. You can see the trainings are running right now. Currently, I am testing a new hyperparameter and the clip large text encoder training, which has arrived just today. So after these tests have been completed, I am going to analyze them, post the results on this research topic, and I am going to update the configuration files. Don't worry, you will just load the configuration, you will just download the latest zip file and load the configuration, and you will get the very best workflow, very best configuration whenever you are watching this tutorial. So that is why following this post is extremely important. The link will be in the description and also in the comment section. Don't forget that. So now our interface started and I am going to load the configuration. For beginning the setup, I have selected the LoRa in the training tab. When you look at the folder, you will see best configs and you will see best configs better colors. And what do these configurations mean? When you scroll down, you will see the description of each configuration. I have prepared a configuration for every GPU. So if you have an 8GB GPU, you need to use this one, rank 9 75 14 MB JSON file. When you enter inside the best configs folder, you will see that the JSON file is there. So according to your VRAM, pick the configuration file. There are slow and fast versions. What do they mean? With the slow version, we are going to get a slightly better training quality. There is not much difference between the rank 1 and rank 6. After rank 6, we are going to lose some quality because of the reduced training resolution and also reduced LoRa rank. If you read the research post, you will see the difference of each configuration. Training under 1024 pixel seriously reduces the quality. Also, I find that LoRa rank 128 is the very best spot. So these three configurations will have slightly lesser quality than these ones. These ones will be very close. Since I have RTX 3090 GPU, I am going to use the very best configuration rank 3. Currently this is running slow on my PC, but with the Torch version 2.4.1 it will be much faster. So go to here and click this icon, this folder icon, enter inside the folder of best config and load the rank 3. Now you may wonder what is the difference of better colors. This is in experimentation. Currently I am training it to decide whether fully switch to it or not, but this uses time step shift sampling and it makes huge impact on the coloring. When you open this file, you will see this very big huge grid And when you look at this grid file, you will see that using the time step shift brings better colors and better environment like this one. However, it also reduces slightly the likeliness. I am still researching it. I am still training it. When we open this image SLI link, you can see one by one comparison. So according to your need, decide the configuration you want. Hopefully, I will complete the research of time step shift sampling and I will decide the very best configuration. Currently, we have two different configurations and their difference is like this. But to be safe, you can use best configs folder right now. However, you can also use best configs better colors too. So look at the grid file, image SLI and decide yourself. Okay, as a next step, you don't need to set anything here. This is for multi-GPU. I also have multi-GPU configs and I will show them hopefully on the cloud tutorial. I am going to also make cloud tutorial for Massed Compute and Rampod. So what you need to set with this configuration, you need to set pre-trained model path. This is super important. The model links are posted here, so you can either download from here or I have one-click downloader here. You see Windows download training models files. If you already have some of the models, make sure that they are accurate models or you will get errors. This bat file will download everything automatically for me. You see it started downloading already. However, I already have them downloaded here, so I am going to just pick them. If you already have them, you can use them. We are going to use Flux Dev version 23.8 gigabytes. The FP8 support also arrived, but I haven't tested it, so to be sure, use the FP16 version. It doesn't matter because we are going to use it in FP8 mode and training with 24 gigabyte GPUs, and it will cast the precision automatically. So select this. You see this is the base model that I have. Now selecting training images is super important and so many people is making mistakes here. If you know how to set up Cohere folder structure, you can already set up yourself. But don't use it if you are not an expert. So in the dataset preparation section, we are going to prepare our dataset. The dataset preparation is extremely important. I have written some information here, how to caption them, how to crop them. I already have auto cropper and auto resize script, but you can also manually auto crop and auto resize them. So currently my training images are auto cropped and auto resized to 1024 pixels as you are seeing right now. These scripts that you will find is extremely useful. Watch this video and check out this script to automatically crop the subject with focus and then resize to get your training dataset. Once you have your dataset like this, copy the path of this dataset, or you can also select the path from here. You see training images directory, click this icon, go to the folder like this and select the folder like this. Now this is super important, repeating. What does repeating means? We are going to set the repeating one because we are not going to use classification regularization images. I have tested the impact of regularization and classification images. You can see the results in this research post. For example, let's open this post, and no matter what I have tried, there is no way to improve the likeliness and the quality with classification regularization images. In none of the cases, it yielded better results when I have used the classification regularization images. You see, you will get mixed faces like this. And if you still want to know what does repeat means, there is a link here. Open this link. In this link, I have asked Cohere to explain what is the logic of repeating. The logic of repeating is initially made to balance imbalanced datasets. What does that mean? Let's say you have 5 concepts that you want to train at once, and one of the concepts has 100 training images, the other one has 20 images, the other one has 30 images. So in machine learning, you would like to make datasets balanced as much as equally trained. Therefore, if you have 100 training images, you make the repeating one, and for other concepts, if there are 20 images, you make the repeating 5 of that concept. However, since I am training a single concept right now, I am going to set repeating one, and I am not going to use regularization images because for flux training, it doesn't improve the results. However, when you train Stable Diffusion 1.5 or Stable Diffusion XL, SDXL, it really improves the quality of training. At the end of this tutorial, I will show you how to load the very best configuration for SD 1.5 and SDXL and train them. Don't worry about that. So we did set the training images directory here. We are going to set instance prompt. I am going to use a rare token OHWX because it contains very little knowledge. Also with Flux training, it is not as important as before, but still use it. And as a class prompt, I am going to use man. Even if you don't use a class prompt, since the Flux model has internal system that behaves like a text encoder and automatic captioning, it will still know what you are training, like you have fully captioned it. So even if you don't provide any instance prompt or class prompt, it will work with Flux. I have also tested it. In the research topic, you will see the trainings results with OHWX man, with only OHWX, and with only man. And you will see that almost in all cases, it perfectly generates your concept. Still, I find it a little bit better to set class prompt as a man, or if you are training a woman, it's a woman. If you are training a car, it's a car. If you are training a style, it's a style. But training for a man, I use man. Even if you don't use it, it will work. If you are training multiple person in one training, you don't need to set a class prompt. Just give each one of them a rare token like OHWX, like BBUG and other rare tokens that you can decide yourself and train all of them at once. But currently this is for single person training, so this is the setup: instance prompt, class prompt, and destination directory. This is super important. The Kohya GUI will prepare the accurate folders and save them at that destination. So I am going to use the installed folder like here. You can use anywhere, and I will save train images like this. And then click prepare training data and watch the CMD. You will see that done creating Kohya SS training folder structure. When you enter inside that folder, you see train images folder generated here. When I enter inside it, you see there is image, and inside image there is one underscore OHWX man. So what does this mean? This means that the one is the repeating. This is super important. If you set this 100, at every epoch it will repeat 100 times. So this is super important. Kohya will always read the repeating number from here. And the rest will be the simply caption of my images. If I wanted to caption them, I could caption them and it will read the captions. If you don't caption your images, it will read the folder name as a caption. So let's also make caption it. Example, I will copy paste this like this. The name of this folder will not be important because I'm going to caption it. So copy this path. And for captioning, I have an amazing application, Joy Caption. Click here. When you get to this post, you will see the installer for Joy Captioning. This is a very advanced application. It supports multi-GPU captioning as well, because I am going to caption my entire regularization images dataset, and I am going to make a LoRa on that. There will be total 20,000 images that I am going to caption. So it supports multi-GPU and also batch captioning. It is already installed. Let me open it and show you how to caption. So Joy Caption 1. Let's start the Windows application. Let's start like this. The application started. All I need to do is give the input folder path here and just start batch captioning. You can decide multiple GPUs, multiple batch size, all is working. This is a very optimized application. There is override existing caption file, append new caption file, and max NIV tokens. You don't need to set these parameters. You can just change the max NIV tokens. I'm going to make a dedicated tutorial for this application hopefully later. You can see the progress on the CMD here. So first it is loading the checkpoints to start captioning. The captioning started and it is captioning the files. When I enter inside this file, you will see that it is generating captions like this. When you open the txt file, you will see the caption it generated for that image. However, if you do captioning, it will reduce the likeliness of your concept if you are training a person or if you are training similar stuff. Captioning with styles may work better. I am hopefully going to test it, but still, if you want to do captioning, you can use this application to caption. I also have compared the captioning effect. So let's search the caption in this post and let's see. Yes, here. The captioning results are here. Let's open it. And when we look at the Joy caption results, there will be a slightly reduced likeliness. However, I didn't see improvement for the environment or generalization or the overfitting. This is because it already captioned itself in the Flux architecture. So whether I caption or not, it doesn't matter much. The likeliness is still there. It's a little bit reduced and it doesn't improve the overall quality. So for person training, I don't suggest captioning, but for training a style, it may work better. As I said, hopefully I'm going to research it and make a tutorial for style captioning. After you did the caption, you still should add an activation token. What was the activation token? Instance prompt. So you can either edit them manually or I have caption editor. The caption editor is posted here. When you go to this link, you will see the instructions and download the zip file. It's a very lightweight Gradio application. Let's open the image caption editor, start application. It doesn't use any GPU, it is just Python code that allows you to edit the images. It is web-based, so it can be used anywhere. So you need to enter input folder path. This was our folder path. Let's enter it and it will automatically refresh scan images. You see these are the images. When I click here, it will show me the caption. I can either manually edit here like OHWX, then I can click save caption and it will save it. Then I can click the next image. Then I can filter images by processed or unprocessed. This is an extremely useful application. So with processed, you see this was the save it processed and these are the still awaiting ones. This is a very lightweight application. Let's make this again as man because I'm going to show you another thing. Let's save caption. Then in the batch edit options, you can enter the folder and you can replace words like replace man with ohwx man and replace all occurrences, and it is going to overwrite all the files, apply batch edit and all captions edited. Then you can check all the captions whether they contain my activation token or not, like this, check word, and you see all captions contains the specific word or phrase. Then when I refresh here and open an image, you see this photograph features a OHWX man standing. So all the captions are now ready to use. Since this folder exists in my images folder, it will train both of them, but we don't need now captioned images, so I'm just going to delete this folder. Okay, let's return back to Gradio interface where we set up. After we click it prepare training data, we also need to click copy info to respective fields. Otherwise, you will see that the image folder is not accurate. You see, it is inaccurate. So click copy info to respective fields and you will see that it did set the folder like this, train images image. So what does this mean? It didn't give the path of this folder. It gives the parent folder path here. So you can have multiple concepts, multiple persons or items, anything inside this folder, and the Kohya will read each one of the folder, and whether you have captioned them or you don't have captioned them, it will read the folder name or the captions and it will train based on all of the images. You can also set different repeating numbers for each concept as I have explained. Like, let me show you. Let's say I have 3 concepts. This can have 3 repeating. This can have 5 repeating. So the images inside this one will be repeated 5 times. Images inside this one will be repeated 3 times. This is the logic of setting up folders. Let's delete them. Now we have set the model path, train it model output name. Whatever the name you give, it will generate checkpoints with that name. Let's say best version 2. Okay, this will be the output model name for LoRa's that is going to get generated. Flux1 selected. Everything is selected. You don't need to set anything. And you don't need to use dataset preparation again, but you can prepare multiple datasets by using here. With Stable Diffusion XL and with Stable Diffusion 1.5, we use regularization images. At the end of this tutorial, I will show that too. So I'm just skipping that part. And the parameters. In the parameters, what you need to set is few things. First of all, how many epochs you are going to train. We are going to train based on epochs, and one epoch means that all of the images are trained one time. When we use regularization images, we use a different strategy. We train 200 repeating and 1 epoch, but since we don't use regularization images and since we use 1 repeating, we are going to use epoch strategy. So if you have 100 images, you can reduce this epoch number. However, you can still train up to 200 epoch and compare checkpoints to get the very best checkpoint. So as you increase the number of images for a single concept, you may want to reduce number of epochs. Currently, most of the people will collect like 15 to 25 training images, maybe 50. So training up to 200 epoch and comparing checkpoints is the best strategy. About the training dataset, this training dataset is not great. Why? Because it contains the same clothing, same background environment, and it is lacking expressions. Many people asking me to generate expressions. If you want to generate expressions, you need to have expressions, emotions in your training dataset. I am preparing a much better training dataset. It is not ready yet. I am still using the same dataset so I can compare with my older trainings. However, hopefully I will make another video for an amazing training dataset. You will see that. So when you are preparing your training dataset, have different poses, have different distances like full body shot, close shot, have different expressions that you want to generate like laughing or crying, whatever you want, have different clothings and have different backgrounds. The quality of dataset is very important. With Flux, it is still very flexible. It is better than the SDXL or SD 1.5. However, as you improve your dataset, you will get better results. One another thing is that make sure that your dataset has excellent focus, sharpness and lightning. This is also very important. Do not take pictures in the night time. So make sure that your images have very good lightning, very good focus and very good sharpness. Okay, let's return back to KoyaGui. So I will leave this 200. You can reduce this based on number of the images you have. How many checkpoints you want to get? You can make this like 10, and after every 10 epoch it will generate a checkpoint, and at the end of training you can compare all of them. I am going to show how to use and compare them. There is no issue with it. So you can make this 10 and compare all the checkpoints and find the very best checkpoint you like it. So this is the most optimal way of obtaining the very best model and checkpoint. But for this one, let's leave this as 25. Caption file extension. If you are going to use captions instead of the folder names, you need to select the accurate caption extension. By default, it is TXT, and TXT is most used one. You can also use caption and cap. I never used them. TXT is just working fine for me. Then you don't need to change anything else here. By default, we are using 128 to 128 network rank. Okay, this is another thing that you need to set. This is super important. VAE path. So for VAE path, we set this ea.savetensor file. It is already downloaded. Let's go to the folder which was inside here. I had downloaded here and EA save tensors file. And we are going to use clip large model. Click here. Let's go to the clip large. Okay, it is also set, and we are going to use T5XXL. Make sure to use T5XXL FP16. It will be auto cast to the accurate precision. So let's also pick that file from our downloaded folder, which is here. And we are all set. You don't need to do anything else. Just save the configuration wherever you want. So I will save downloaded folder by clicking this save. If you want to reload, you click this or click refresh to reload. You see the refresh will refresh. You can also repick, but sometimes when you repick, it may not refresh. So click this to refresh. Let's select the save it config again, which was this one. And let's refresh. Yes, I can see the configuration reloaded. Currently, none of the configurations are training text encoder, clip large. As I said, I am researching it right now, and hopefully I will update the configuration according to it. The training of clip large will increase the VRAM usage slightly. It increases like 800 megabytes on 16-bit precision. It will also slow down slightly. You see from 8.82 second IT to 8.56 second IT on a 16-bit precision training on a 6000 GPU. Okay, as I said, we are ready, and before clicking start training, you need to check your VRAM usage. Try to make your VRAM usage under 500 megabytes. Currently, you see my computer is using 3.5 gigabytes. Why? Because I am running OBS Studio, I am running NVIDIA broadcast, and some other applications. So try to reduce your VRAM usage to 500 megabytes. If you are on a limited VRAM, how you can reduce it? Go to the startup, disable all of the startups, restart your computer, and check the performance and GPU and see how much VRAM you are using. Alternatively, you can also use another application which is NVITAP. So to install NVITAP, pip install NVITAP. I already have it. Then type NVITAP and it will show you the VRAM usage, GPU utilization, how many GPUs you have. You see I have 2 GPUs. So this is the way of also seeing exact VRAM usage. You see this one shows 3.8 gigabytes I am using. This one showing 3.5 dedicated GPU I am using. So you can use either way. Then click start training and watch the progress on the CMD window of the Kohya. You see it is starting everything. You should read the messages appearing here. If you see this error, Xforms can't load, it is not an issue. Currently we are not training Xforms. Actually I had fixed this, but I'm going to fix it again. But it's not an issue because currently Xforms is not working better than the default cross attention, which is SDPA. I will also fix Xforms later, but you can ignore this Xforms message. It doesn't make any difference. We are not using Xforms. So what are the messages we see here? This is important. You see it has found one repeat. It has found 15 images. So one epoch will be 15 steps because the batch size is 1. Increasing batch size, I have tested it too. It doesn't bring almost no speed gain, and as you increase batch size, you will get lesser quality trainings. Batch sizes should be used only for speed, and in this case it doesn't increase much, but you can use multiple GPU to get almost linear speed increase. I have explained the batch size on the Patreon post, so read that section. And you see regularization factor is 1, total steps 15, train batch size is 1, gradient accumulation steps 1, and 200 epochs. So it calculates the number of total steps, which is 15 divided by 1 divided by 1. Why? Because this is the batch size, this is the gradient accumulation steps, multiplied with 200, this is the number of epochs, and multiplied with 1, this is the regularization images, which we don't use, so it is 1. When you use it, it is 2. And total, it will be 3000 steps. Okay, I hit enter because when you touch the CMD, it will pause the CMD window. And you will also see that it didn't find any captions, it didn't find regularization images, so it is going to use class tokens ohwxman, which it reads from the folder name. So everything is looking good and it will load and start training. The speed is not very great and you will get a better speed as it progresses. In the beginning it will show not an accurate speed. Once the Torch 2.4.1 publish it, we should get speed like 4 to 5 second IT on Windows with RTX 3090 GPU. But as I said, don't worry, I'm going to make cloud tutorials and it is going to be super fast on cloud GPUs. You will be able to run very powerful GPUs and it is perfectly trainable. So this is how we do training on Windows. It will be same on Mastered Compute and Rampot as well. The procedure will be same, just the starting and installation will not be same. So just wait until these checkpoints are saved. And how we are going to use it afterwards. Since I already have trained them, I am not going to wait training. In this repository, I have the training files, which is trained with the exactly same configuration. You see best version 2. So I'm going to download several checkpoints to test on my computer. When you are training, there is one thing that is extremely important that you have to be careful of. Open the task manager, go to the performance tab and go to your GPU. You see that there is dedicated GPU and shared GPU memory. When you are doing training, if it uses shared memory, it will become slower like 10 times, 20 times. So this is the criteria that you need to be careful. Compare the shared GPU memory usage before starting the training and during the training, and make sure that it doesn't use more shared GPU during the training. If it uses, then you will have extremely slow training speeds. This is really important. This is also valid for all of the AI applications you use, like Swarm UI, like Forge Web UI, like Automatic LLM Web UI, whatever that comes to your mind. When it starts using shared VRAM, that will make your application slower like 20 times, because it will start using the memory of my computer, and memory of my computer will be way slower than the GPU memory. Moreover, if you have a low RAM, in some applications you may encounter problem, but it is not an issue. You can set virtual RAM memory. So you see, currently I am training and I am not using any shared VRAM. My dedicated GPU memory still has a space to go, like 3 gigabytes. This is super important. And about RAM memory, you can set virtual RAM to have more RAM memory. Memory is usually important when it is first time loading. So if you have a limited RAM, you can increase the virtual RAM memory to not have any errors. To increase the virtual RAM memory, click this PC. In here, click this PC properties. It will open this properties. In here, go to the advanced system settings, and in this screen you will see the settings in the performance, and in here go to the advanced, and you see I have virtual memory. Change it, set one of your fast drive, and you can set custom size. Currently my virtual RAM memory is set here. You see system managed size, and it will allocate as necessary as virtual RAM memory. Okay, this is the way of it. So during the training, you will see that it will save checkpoints like this, and you will see their saved locations. And where they will be saved, they will be saved in the outputs folder. You see output directory for trained model. This was automatically set by the GUI when we have used the prepare training data and copy info to respective fields. After you click copy info to respective fields, you can change the output directory for trained model. You can directly give the folder path of your Swarm UI, your Forge Web UI, wherever you are using your Conf UI. So my models will be saved automatically here. When we open that folder, we will see the saved checkpoints like this. So these checkpoints are 2.4 gigabytes. Why? Because Flux model is very big. It is 12 billion parameters. Moreover, we are saving as float. So we are saving with the maximum precision without any quality loss. If you want to reduce the file size, you can also save as FP16. I haven't compared. Some of the followers say that BF16 is working bad. So if you need a lower size, save as FP16. If you want to have the maximum accuracy, save as float. Save it precision will not change VRAM usage, will not change the VRAM usage during training or during the inference. So now it is time to use the saved models with the Flux model itself. So how we are going to use them after training has been completed? You can use them with Conf UI, with Swarm UI, with Forge Web UI. At the moment, I prefer to use in Swarm UI. I already have a main Swarm UI tutorial. It is amazing. And I also have a Swarm UI tutorial for Flux. Moreover, I also have Forge Web UI models downloader and installer for Rampod and also for Massive Compute. I will show the cloud service providers in the cloud tutorial, but I will show how to use in my computer at the moment. So I will move these files into my Swarm UI models folder. You see, it also saves the TOML file and the JSON file wherever you are saving them. So let's select the generated models and move them into our Swarm UI model folder. My Swarm UI is installed here. When you watch the tutorial, you will see it. I will put the generated LoRa files into the models into the LoRa folder here. This is important. This is where you need to put them. Before starting training, as I said, you can give this folder path. So after you have set the copy info to respective fields, go here and change it like this and save your configuration. Then it will save the generated LoRa files into this folder for you. Okay, so I'm going to start my Swarm UI. First of all, I'm going to update it. When you are using Swarm UI, you should update it always. You can also use Forge Web UI or Conf UI. I prefer Swarm UI because it is amazing. It has so many amazing features. It also uses the backend of Conf UI, so I will use launch windows.bat file to start it. And my Conf UI is starting. There is also a trick that I'm going to show you. This will give you a lot of performance boost. If you have a RTX 4000 series GPUs, click this pencil icon and add extra arguments dash fast here and save it. This will hugely speed up your generations with Swarm UI when you are using Flux model. Backends are still loading. Go to the server, go to the logs. Let's see in the debug. So we can see that it is starting server. It is loading everything and data getting refreshed. Okay. So now I am ready to generate images. For Flux model, I am going to use CFG scale 1. When you use CFG scale 1, you see negative prompt is disabled because Flux doesn't support. I prefer 30 steps. Based on your GPU, you can set it. I'm going to use resolution 1. I'm going to use sampler UniPC. I find this the best. Scheduler will be normal. And you can set the preferred D type here. Since this is a 24GB GPU, I am going to use this one. However, you can also use 16-bit on a more bigger VRAM having GPU. This is a good one. There are also quantized models, but I haven't tested LoRa's on them, whether they are working or not. So I don't know. And I can say they will work. And in the models, I have Flux 1 version dev FP8. You can also use the FP16 model. They should work exactly same actually. So to be sure, I am going to use the FP16 model. I already have it here, so let's copy it and let's copy it into our models folder. It goes into the stable diffusion. Let's see. Yeah, it goes into the unit because this is not quantized model. It goes into the unit. The quantized models goes into the stable diffusion folder in the Swarm UI. I could also give the path of this file from this folder before doing the training, so you don't need to have duplicate files. What would be the case? The case would be I click this icon, then I go to my Swarm UI installation, which is here, Swarm UI inside models, inside unit, and I can select this. So you see, you can give the any file path in Kohya GUI, it will just work. Then refresh the models and the Flux development arrived. This is an FP16, 16-bit precision model, but since I'm going to use 8-bit, it will auto cast it. Before starting using the LoRa, let's generate an image. And a very good part is that in the zip file, I have shared some test prompts. So let's open the test prompts from here. And for example, let's generate this image without our LoRa. And let's hit generate. You can watch the progress in the server, in the logs, in the debug. So it is going to load the model and you see model weight D type, manual cast. So it is going to do everything automatically for me. I can watch the VRAM usage here. It is using ConfUI, it is very optimized. I have selected the model. You see the Flux 1 development model is selected. As I said, I am not sure whether it is working with the quantized models or not. I haven't tested yet, but you can test. For now, make sure to test with the development model. Then you can test on quantized models as well. And this is my VRAM usage currently. Don't worry, you don't need such VRAM. It works as low as 6GB having GPUs. It is extremely optimized. Since I have a more VRAM, it is using more VRAM. When you have a lower VRAM, it will use lower VRAM. Moreover, I can also use my second GPU. It is amazing. So all I need to do is I am going to add a new ConfUI self-starting. Click here. Okay, I will make this like this. Extra arguments, starting script, and I will make this GPU ID 1 and save. So when I generate multiple images, it will use my second GPU as well. Okay, the image is almost ready. I am also using segment to inpaint face. This is not mandatory. In the main tutorial, I explain everything. It is a little bit slow on my GPU, but you can use Cloud always. We can see the IT per second. Okay, where is it? Let's generate another image to see it. Let's also see, yeah, it is fine. Okay, now it is starting to inpaint face. Okay, face inpainting speed is 1.5 second IT. And it is doing 18 steps. Why? Because I say that 0.7 denoise strength. It is called different here. It is called as see image creativity. So it is doing 70%. And since I use 30 steps, it is doing 21. Actually, it should do 21, but it did 18. Okay, this is the image we got. Now I prefer to use flux guidance scale 4. I forgotten that. Okay, then how am I going to use my LoRa's? Go to the LoRa's tab here, refresh, and once you refresh, you will see your flux LoRa's. You see type flux 1 LoRa. For example, let's use the 150 epoch and hit generate. So now it is going to use my LoRa. We can see in the backend, it will load. You can see everything here. Swarm UI working much better than the Forge Web UI when you are using LoRa. When you are using Forge Web UI, it first process LoRa, it takes extra VRAM. However, with Swarm UI, it doesn't do that. Also, when you have more VRAM, it will be faster. Since I am using some serious VRAM right now, it is using a lot of VRAM. I am recording a video. It is also making, and let's also close this too. Try to reduce your VRAM usage as much as possible. And I am already using a lot of VRAM when I am recording. We can see the preview here. First it is generating image, then it will inpaint face to my face with the prompt photo of OHWX man. It is inpainting the face now. This is not mandatory, but inpainting face, especially in distant shots, will improve the face quality. Moreover, in my training images, I have eyeglasses, you see. But since Flux has internal text encoder, it is able to separate my eyeglasses from my face. Thus, in this image, I don't have eyeglasses. This is also a little bit overfit image, but I am working on a better workflow. Hopefully, I will update it and it will become much better. So you can add here with eyeglasses and you will get more likely image. Let's see, generate and double generate. So once I click it double times, it will also start using my second GPU. It should start. Let's see. I think first it will load into the second GPU, then it will start. Okay, let's see the server backends. Okay, it shows here running backend. Okay, for some reason it didn't start. And if preview disappear here, you can go to the image history, refresh. The last generated images will always appear here. You can see them, their features, flux guidance scale, the LoRa. You can also set different LoRa weights from here. Okay, image is generated and you see it is now much more resembling. We can see from the training images, it has a perfect resemblance. It is, as I said, more overfit. With the fine tuning, full model training, I think this overfitting problem will be solved. I am also doing more research right now, as I said. So I will update the config as I get better config. Every day something new is arriving. Also, you may use overfit, overtrained model checkpoint. So how we are going to test and find the very best checkpoint? This is a super important part. Let's see also other generated image. If you have RTX 4090, it will be way faster than this. It will be many times faster than this. You can always see the step speed here. It is around 1.5 second IT for me. And the second image also generated perfect resemblance. Okay, so how am I going to find the very best checkpoint? To do that, we go to the tools and in here we select the grid generator. In here in the first tab, I use LoRa's. So find the LoRa's from here. Let's find it. You can also type to filter like this, LoRa's. When you click fill, it will fill all the LoRa's. Then you can delete the ones that you don't want to test. Let's test starting from the 50 epochs. So these are epochs, epoch 50, epoch 75. If you save based on the step count, it will have a different naming. So the last one will be the 200 epoch. Then you can test multiple prompts or you can use this prompt for testing. If you want to test multiple prompts, I have already prepared prompts. So these prompts are shared here. You see test prompts, no segment inpainting. This doesn't have any segmentation inpainting. And I have test prompts here, test prompts with eyeglasses and test prompts. Let's see, one of them doesn't have eyeglasses. Okay, this doesn't have. So I am going to change this name. I will fix this. Test prompts without eyeglasses grid formatted. So you just copy this. By the way, in the grid, this is the prompt separator, you see, like this. Then copy paste it here. You see it has splitted each prompt, and now when I generate a grid, it will test all of the models for me. Let's see, generate. This time it should use the second GPU as well, I believe. Let's see what will happen. Okay, now it started loading onto second GPU as well. So when generating this grid, it will use both of my GPUs. However, with my GPUs, this will take huge time because there are 274 generations. This is estimated this will get better, but this will make a huge grid. You should wait for it to update. You can rent for A6000 on Massed Compute and use all of them at once. It will be much faster. In the Massed Compute tutorial, hopefully I will show you. Okay, the first image is generated. The first image for verifying the model sanity. You see, it is perfectly able to generate a supercar image, nothing like me. So the model sanity is perfect. It is still keeping its sanity. And what kind of results we are going to get after these grids generated. For now, I will interrupt this with interrupt all sessions, and I will show you from my cloud computing. So in the Swarm UI Massed Compute tutorial, there is these new instructions. Copy this. First of all, you need to install this. Okay, let's copy this and open a new terminal here, new window, and paste it and hit enter. This will start Swarm UI on Massed Compute, but it will give me a cloud URL that I can use on my computer. It will be here. It is Cloudflare. Let's copy and paste it and open. And this is where I do my testing, my experimentation. When I go to the tools and grid generator, I have so many previous tests like this. You see, I have 8 GPUs running there. For example, let's open one of them. Okay, let's open BestNiv 150 epochs. And when I click here, it will show me the grid results. I explain all of this in the main tutorial. In the advanced settings, you can select to show which prompts, you can select which models to show, and we will get a grid like this where we will be able to compare different checkpoints LoRa's. So by analyzing this grid, you need to find your best liked checkpoint. Usually 150 is good, but it depends on your training dataset. So generate a grid, analyze all of the generated images. You will see at the top the model used. Also, when you click the image in the bottom, you will see which LoRa is used. For example, for this one, the used LoRa is, let's see, this one, best version 1 5E5 150. Also, it shows the LoRa used name here. So this is the way of finding the very best LoRa checkpoint that you have. For example, on this Massed Compute, I have 8 running GPUs and I am able to generate ultra fast images. This is how I do my experimentation. There is no other way to do this many trainings on a single GPU. So you need to spend some considerable amount of money. Thankfully, Massed Compute is supporting me. So if you are wondering how did I generate those amazing pictures that I have shown in the intro, I have generated amazing new prompts and I used the wildcard feature of the Swarm UI, and I have written all these posts in this wildcard and I have generated 9,999 images until I stop it. The new prompts are shared in the test prompts in the 340 prompts used as wildcards. Okay, we have covered everything, and there are also extra information here how to train on and use on Rampot and Massed Compute. The instructions already included in the file. You will see that Massed Compute Kohya Flux instructions. You will see Rampot install instructions. Hopefully I'm going to make separate tutorials for them. Also, I suggest you to save your models on Hugging Face. If you want to save them, download them fast. I have amazing notebook and tutorial for that. Watch it. And it is also asked of me how to do SDXL and SD 1.5 training with the newest Kohya interface. So everything is same, almost same. Therefore, I will quickly show you. For example, let's begin with SDXL. Let's open the best configuration. In the very top, we will see the configuration. Here, let's download the Tier 1 24GB slower version 2. There is also Tier 2 low VRAM version. And the configuration loaded. Let's close the Swarm UI and let's open our latest Kohya installation, which is here. Let's start it again. The configuration is downloaded. Kohya is starting. Okay, then these are full fine-tuning configurations, not for LoRa. So select the Dreamboot tab here, go to the configuration, click this icon. By the way, This is ST3 Flux branch. So there may be some errors. You need to install it with the normal way. If it doesn't work, I don't know. I didn't test. So let's go to the downloads, select the file, and it is loaded. You see this is Dreamboot, STXL is selected. We do FP16 training. Now you set everything exactly same. Trained model output name, you put the image folder name, pre-trained model path. But this time what differs? You should use regularization images. And regularization images is posted here. I have amazing 5,200 images for both women and men. So what you do when you go to the dataset preparation, you also put regularization images and you put 200 repeats, or the number of repeating may depend on your number of training images. Let's say you have 50 training images. Since we have 5,000 regularization images, you can make this 100 and you can train 2 epochs. But let's say I have 15, so I make this repeating 200, put my training images path here. Then I also go to the downloaded regularization images. Let's see. For example, these are 768. I also have 1024. Yeah, here. This is an amazing dataset, super high quality. I tested, compared the effect of using regularization images, and it's mind-blowing, especially with one trainer. And you put it here. This time repeating will be 1. You just type OHWX and man, it will auto-generate the folders for us with accurate naming. Let me show you. So let's make the destination an example place like music folder D. Usually you shouldn't use users folder, but this is just for an example. Prepare training data. Watch the CMD window because copying may take time. Wait until you see done. Currently it is copying everything. We can see image 200 OHWX man is copied, and it is also going to copy man dataset. Okay, this one copy it. And in the reg folder, okay, this one copied. You see the regularization images is put into the reg folder, and the training images is put into the image folder. And inside reg folder, man images are named as one man because one repeat and man class token, and the training images are 200 and OHWX man. So what other thing changes? Now we train only one epoch. So how we are going to save checkpoints in this case? To save checkpoints in this case, let's copy info to the respective folders, and let's also select pre-trained model path. I have already models here, like let's see STXL base, for example. By the way, which models I suggest? I suggest you to use realistic vision version. Let me see. Okay, I suggest you to use RealViz XL4 for training STXL, and for training ST 1.5 I suggest, what was the name? Hyperrealism version 3. So you should select those models, and when you click the print training command, it will show you the total number of steps, and it is now 6,000 because I have 15 training images, I use regularization images, and I have 200 repeating. Therefore, let's see if it does show the calculation. Yes, 200 repeats, 15 images, it makes 3,000 steps per epoch. Since regularization images are used, it is multiplied by 2. So total 6,000 steps. And let's say I want to save every 20 epoch. So normally it would be save every 20 epoch, but now I don't have that option since I train one epoch. So I will save number of steps. When you divide 6,000 to 10, because we want to get 10 checkpoints, you will change the save every end steps. Let's see here. So if I make this 601, it will save as equal as saving every 20 epochs compared to the repeat one. This is the logic of it. This will save 10 checkpoints during the entire training, and this save every n epochs is 1 and epoch is 1. This will save full checkpoints. For STXL it will be over 6 GB. For SD 1.5 it will be like, I don't remember actually, but it will be big. So if you need LoRa's, do this way of Dreamboot fine-tuning training, then extract LoRa. It will work much better than training LoRa with STXL or SD 1.5. I have tested it. For extracting LoRa, I have an amazing post here. It shows how you can extract. Let me also show you quickly. Go to the utilities, go to the LoRa, and in here you will see extract LoRa. Whether it is SDXL or not, you pick it here. If you don't pick SDXL, it will extract as SD 1.5. If you pick SDXL, it will extract as SDXL. Currently it doesn't support Flux. I don't see it here. Oh, here, click here. Extract LoRa also arrived. I haven't tested it yet. I will hopefully test it after I train full fine tunings. So select your fine tuned model. This is the generated model. Select the base model. This is like RealViz XL4. Set the path where you want to save. Save precision, you can save as float, it will double the size. Load position, you can load as float. Set this minimum difference 001, so it will also save the text encoder because I trained text encoder as well. And you can set network rank dimension 128 to 128. This is it. For SDXL, you just select SDXL, and that is the way of extracting LoRa's and using them when you do training with SD 1.5 and SDXL. In my post, you will see very detailed instructions, so always read the posts on here. Moreover, you should join our Discord channel. I am always on Discord channel. You can message me there. At the very top of the post, you will see SE Courses Discord. When you click it, you will see our Discord channel. We have over 8,000 members, over 1,000 online members. Just click join server to join. Moreover, we have Patreon exclusive post index. In here, you will see all of our amazing sharings. You can just do Ctrl F to see them. Also, we have Patreon scripts updates history. You will see which scripts are updated last and what changes are made. Sometimes I don't write the full changes. And we have Patreon special generative script list. This shows the useful scripts that you can use for other tasks, other jobs you have. And you can also go to our GitHub repository here, Stable Diffusion Generative AI. When you go to here, you should actually please start it, fork it, and watch it. Also, if you sponsor, I appreciate it. You see, we have 2,000 stars, we have 200 forks and 82 watching. Moreover, we have a now subreddit. Go to subreddit SE Courses. I follow every comment and post made here. I will reply all of them. I am also sharing a lot of announcements here, and I have a real LinkedIn account. I am not an anonymous person, obviously. You can go to my LinkedIn account, you can follow me, you can connect with me, it is fine. I also reply every message here. This is it. I hope I have covered everything that you have been wondering. Hopefully see you in the future tutorials for Flux, because a lot of tutorials are coming, like training on Rampo, training on massive compute, and fine tuning. I think fine tuning will be way better, and I am going to update this post and write the very newest findings that I have. Also, you should check out this lengthy research post because you will find a lot of information here. Let me show you one thing. For example, Flux training discussions with lots of information on this post. You can open them. And there is a new information that shows why Windows training is currently slower than Linux training. With Torch 2.4.1, hopefully we are going to get an amazing speed boost on Windows without doing anything and without losing any quality. And it is 75% completed, so it is almost there. I will update my installer scripts, don't worry about that. Hopefully see you in another amazing tutorial video.